Hello students, let us continue our discussion on PN junction diode. Last time we have discussed about diffusion current, but what is the impact of diffusion current? That's what we are going to discuss now. So due to concentration gradient at the PN junction, we know that the electrons will jump from or will diffuse from N side to P side. So electron movement initially is from N side to P side. Okay. And as I told you in the last video also, P side as it is neutral. N side as it is also neutral. Why? Because we have silicon which is neutral and we add aluminum which is also neutral to make a P type extrinsic semiconductor. However, the holes will be generated because aluminum has only 3 electrons in its valence shell. Similarly, silicon is neutral and phosphorus that we add to make it as N-type is also neutral. So together, the whole thing is neutral. However, the extra electron in phosphorus, after the phosphorus has made 4 covalent bonds with silicon atoms, the additional electron, the 9th electron, okay, now will get into the conduction band, and that is how you have electrons as carriers on N side, but still it is neutral. Now, since electrons have jumped or diffused from N to P side, so as a whole, P side gets negatively charged, and N side, which loses electrons, gets positively charged. And therefore, let me draw the same here. So P side gets negatively charged. These electrons will stay nearby the junction. Why? Because there are so many holes on P side that they will take the electrons. I mean, as the electrons jump across the junction, the holes on P side will take those electrons, will not allow them to pass long, through the P. And therefore, nearby the junction, you have a positive charge generated on the N side and negative charge generated on the P side. And this whole thing will result in a electric field, okay, directed from N to P side. Okay, so for your understanding, let me write these important statements. Okay, as diffusion current flows from N to P side, or basically from P to N side, because electrons are from N to P, but current generally is taken in the opposite direction, as you know from the chapter of current electricity. Now, as the diffusion current flows from P to N side gets positively charged, and this charge is concentrated near the junction only. Okay. Similarly, P side gets negatively charged, and all the negative charge is nearby the junction. So few layers nearby the junction on the P side have negative charge, and a few layers on the N side have positive charge. However, we schematically only draw 1 plus 1 minus here, but it is not so. Okay, so if you look at the junction, so from the junction, if you go few thousand layers this side and this side, so on this side you will see negative charge, on this side you'll see positive charge, and therefore there will be a field in between. Okay, from N to P side. So these these are not induced charges, these are actual charges, okay, that have gone from one place to another place. These charges generate an electric field. So as soon as the diffusion starts, the electric field also will start, As the diffusion, okay, more and more diffusion happens, the electric field strength keeps increasing. Okay. Now, the electric field generated, because it is from N to P, okay, causes drift current. That means our normal current, which you have discussed, about which you have discussed, okay, in the current electricity chapter, okay, that current only. It causes drift current, but this will be from N to P side. Okay, this is because you know from current electricity that if electric field causes current, the current and electric field will be in the same direction. J equal to sigma E, J bar equal to sigma E bar, where J bar is current density and E bar is electric field. You have the Ohm's law, which tells you that current and electric field shall be in the same direction. Now, as you also know, if current is from N to P, it means actually electrons are going from P to N. Earlier, diffusion current was from P to N. That is because electrons are jumping from N to P side. Now, because of the electric field, electrons will go from P to N side. Electrons will go from P to N side. Okay. Now, but where are the electrons on P side to go from P to N side? You should understand that the P side also has electrons, but they are in minority. These minority carriers are enough, okay, apart from the strong electric field that the diffusion generates, okay, the electrons, the presence of electrons on P side is another reason why the current goes from, okay, N to P side, or electrons go from P to N side, okay. This drift current is due to drift of minority carriers, that is electrons, okay, from the P side to N side. So the minority carriers that are electrons on the P side, they jump to N side, okay, and as electrons go from P to N side, you can say the drift current is from N to P side. It's a very easy thing. So diffusion current is from P to N, drift current is from N to P. Now, when these two currents, the above two currents that we have discussed, become equal, okay, steady state is achieved. Okay, so we say that there is a steady state that is being achieved when these two currents become equal. Okay, now although the number of electrons are small, okay, because on the P side, the minority carriers, the electric field, the strength of electric field is so large that it will cause enough current. And actually speaking, one more thing you should understand, as electrons come from N to P side, so nearby the junction, the concentration of electrons on N side decreases because they have jumped to P side. So initially concentration is high, so diffusion current is high. Now the diffusion current, high diffusion current, lets the electrons go from N to P side. So concentration keeps decreasing, even the drift current keeps decreasing. But as more and more electrons jump from N to P side over time, the electric field increases and it slowly increases the drift current. So from the start, diffusion current decreases, drift current increases, they both match, okay, and that is when you say steady state is achieved. That is when you say steady state is achieved. Okay, so at steady state, due to drift, the electrons are going from P to N side. Due to diffusion, the electrons are going from N to P side. So this, travel of electrons on either side, okay, in either direction, keeps on happening. Okay, this will, like your chemical equilibrium, this keeps on happening. The reaction keeps on happening on either side. However, you have to understand, okay, this equality of drift and diffusion happened at certain electric field. It happened at certain electric field. And therefore, while the steady state is achieved, you don't have zero voltage between P and N. You have some voltage between P and N. That you have some voltage between P and N. Okay. So this is very important, okay, for the students to learn. Okay. Now, after this, we look at the forward biased PN junction diode and its operation, and reverse bias operation of PN junction diode. That we do in the next video. Thank you.